Hello everyone and welcome. Today I want to take time to thank all the people that are subscribers to this channel. Whenever you subscribe and you pay attention, it gives a lot of encouragement, and I really want to thank each one that has taken time to do that, and that means a lot to any of us who make videos and post things like this. We really appreciate it, and I hope that it is always something that is useful and helps somebody to consider all the things that we put out there and explore these subjects. Whether we're right or wrong in some of the things we talk about, it's always good to explore the subjects. And I want to thank everybody so much for subscribing to my channel, and I want to also say a special thank you to Antarctic Warrior. He's a great YouTuber, a great flat earther, and I want to give a shout out to him. And today I want to talk about magnetism on the flat earth. That's going to be the subject that I'm going to try to discuss in some detail. Really don't know how much that I can go into this subject because there's just so much I don't know. But I do want to talk about it, and the reason is to provoke people to discuss this and to think about it and to question how things really work. The world we live in is so strange, and we think we understand it until we start to explore what we think we know. And then we find there's faults and gaps in the knowledge that we think we have. But anyway, on this little model here, this would be the North Pole at the center of the flat Earth, and this, of course, is the southern pole, the boundary, which is completely different from what you would see on the globe model. The magnetic field around our world here has got to be very strong, very powerful field. And it's really hard to say how this thing actually works because there is so many things involved in it. There's so many variables that affect this magnetic field. On our Earth, we have this huge body of salt water that surrounds the flat Earth. And this water is in motion, and that makes it become electrical when it's in motion. But as the tides move in and out, it causes some sort of an electrical current in this body of water. And that could be something that contributes to how the field works. Also, you have the sun and the moon that revolve around this. And the whole thing seems to work in two ways. One, it works like a clock. And the sun repeats the pattern and the moon repeats the pattern around the flat Earth. And it works just like a clock. And Gleason's map shows this probably better than any map out there, how the flat Earth works like a clock. And then on the other hand, it works a lot like an electric motor. When you consider all the energy from the sun that's put into the atmosphere, and you have all the energy in the oceans and in the water, all the minerals that are in the earth itself, it works a lot like an electric motor. Now, if you move from, say, down here in the south, and you're using your compass, and you move to the north, as you enter into the Arctic Circle up here, the compass begins to behave in an odd way. It'll start to spin and form all sorts of weird circles and do all kinds of crazy stuff, and it's just not accurate because everywhere here is north. And the field just kind of goes crazy. Now, when you get down to the southern pole, down here to the South Pole, which I can show it out this way, things are completely different. When you try to search for information about how magnetism works at the South Pole, there's just not very much out there to find. I've tried to do some research into this. I wanted to find some compasses that are made for this area, and they are very hard to find. I wanted to study about how the southern pole works and all these things, and it's just hard to find information about this. So at this point, I'm going to speculate and just give my own ideas here, and everything that I'm about to say can be completely wrong. I'm going to admit that before I even start, that everything I'm saying here can be completely wrong. But it may be also true. If the Earth, being a flat disk and working like a flat magnet, like a donut magnet, then the fields may react funny depending on where you are on this Earth. For instance, this field may not be as strong as the field in the south. And this is just my own opinion, but I believe that the southern magnetic field may be the stronger field of the two. Or at least in size, it's larger. And I believe that it is actually stronger. I don't know why that is. Maybe it's because of the shape. I just don't know. But anybody that can explain this any better, I mean, I'm willing to listen. I know a lot of you people out there are too. We want to learn. We want to understand how all these things work. But I believe that this field, this electrical field out here, is stronger than the North Pole. Now, other flat earthers, they say that that the North Pole is the only magnetic field, and there isn't one down here. I don't agree with that. They may be right, but I really don't agree with that. I need someone to prove that to me in a better way, because if you have a North Pole, you always have a South Pole someplace. But anyway, I would love to see other flat earthers do research into this subject and explain this in better ways than what I can even dare to do. But this field is, it's hard to say really. It may be created by the sun revolving around the Earth and creating an electrical field above the Earth and interacting with the water down here, interacting with the salt water. Could be, and it could not be. I may be completely wrong on that too, but anyway, those of you out there who have very scientific minds and understand magnetism and electrical fields in water could probably explain this really well. I will show you an example here of a disc magnet or donut magnet, and I'm going to try to do a small experiment, and my experiment may not mean anything. I don't know, because I'm still learning just like a lot of you people are, but I want to give you something to think about here. And I'll have to readjust my camera just a little. Okay. Now here is a disc magnet, and it looks a lot like the picture I've been showing you. If you take a needle and you try to bend it toward the center, which would be the North Pole, if you notice it begins to spin like the compasses do. And when you go this way, it seems the pull is even stronger. At least in my opinion. I may be wrong about this, but it seems the pull is even stronger at the edge. Now, what I've tried to do, I've actually tried to make this needle come on the inside of this circle and attach itself. But when I release it, even when it's leaned forward toward me, it flies back to the edge. It goes to the outer edge. So that's where I got my opinion that the outer edge is the stronger part of the magnet, or magnetism. So let's try this again to show you that we'll do that every time. And there it is. It goes to the edge. I don't know why that happens, but it does. It always goes to the edge. It doesn't matter if I try to lean it in, it still goes to the very edge of this. Now, maybe this means something in the flat earth model. I don't know. I cannot be sure. I just don't know enough about it. But I'm saying there's a possibility that the outer edge could be stronger. They say it affects the compasses different down there. I've heard people say that you cannot take a compass that's made for the northern hemisphere and get it to work at all or to function correctly in the southern hemisphere. That weird things happen. I haven't been there. I haven't tried that. I don't know. I can't verify it or deny it. But I have heard others talk about it, and they say something weird happens with compasses in the southern hemisphere. And this little experiment makes me believe that that's very true. When I try to pull this needle toward the center and release it, it ends up on the edge. So some of you people out there may have a lot of ideas on this. You may be able to explain all this in a far better way than what I can. But anyway, I've been thinking about this for some time, and I wanted to put it out there and let it be something to consider as we all study this subject. I wish we all knew the answers, but we don't. We have to work on it from whatever angle that is available to us and do our own experiments and tests and all these things. Some time ago, a person was criticizing me on the internet and told me that I needed to learn how to use a compass. Well, I didn't bother to argue with the person that was making the comment. I didn't even respond to it. But as far as compasses, are concerned, I do know a little something about compasses. I actually like to use compasses, and these are just a few of the ones that I own. This one with the wristband, that's a small compass that you wear when you hike in the woods or whatever. It's really useful. First time I ever used it, I really liked this compass. It's one of those jobs from eBay. It wasn't very expensive, but it's really, really nice. And this one, let me get this down here. This compass is your base plate compass. A lot of people talks about these when they teach how to use maps and all that stuff. And they're a very nice compass. And here is a compass I've never seen on YouTube. And this one I ordered from eBay also. It's a base plate compass that's also a sight compass. Now you will get some sun reflection off the glass, the glare, and I don't like that. But for a map compass, this thing is really awesome. You can put it down there and it gives you about 6 inches to work with on the base plate. And this other one is a I cannot remember the name, I'm sorry, a military type compass. And the thing I like about this one is it has this little viewfinder that you can look into and see the degrees. It's really great. I like this one. And one more thing that I'll mention here, but I'm not going to go into this subject, but I will show you an example of it. This is a solar compass that I have been working with for some time. And it looks very simple, so simple that you can laugh about it. It doesn't look like much of anything, but I promise you this works. And if you need to know your direction for north, this will show you north. And it's all about 90-degree angles and how you align the shadow from the sun. You don't have to put sticks in the ground. You don't have to wait 15 minutes to take a reading if the sun is out. All you need to know is if it is before noon or afternoon. That is to use this. If you know the time of day, you can get a very accurate reading on north with this. As strange as this thing appears, it actually works. I've never seen anybody else use anything like this. And I came up with it on my own because I wanted to find a solar compass that was reliable, and the others that I have seen just didn't work the way that I would like for them to. So I studied the subject for a while, and I discovered that it was possible to find north very easily using a solar compass. And it seems to work any time of the year, winter or summer. I've tested it in the winter and the summer, and it seems to work just fine. And I think it would work below the equator just as good, but it would just be facing, the shadow would be facing in a different direction, of course, but that could be worked out very easily. Anyway, I know I'm off subject here with all this, but it does relate a little bit to what I'm talking about. Okay, now back to this. For all you people out there that are studying about the flat earth and how things work, we need to know how this magnetic field works. We need to understand this, and I'm sure there's other people out there that can really hone in on this and discover things that I don't even know how to comprehend. So I wanted to put this little piece of information out there, and I hope you enjoy it. Like and subscribe, and I really appreciate all the subscribers that have subscribed to my channel. In the future, I'm going to create other videos that are more Bible related, and I'm going to deviate away from the flat earth subject and probably do a study on the tabernacle in the wilderness. And I hope you enjoy that, because I plan some very interesting things with that. So for now, God bless, and everyone have a good day.